We've already seen a number of different ways that we can relate polygons and other geometric objects to each other. We started by talking about segments and angles and congruent segments and angles. Then we looked at parallel and perpendicular lines, saw a number of postulates for telling if two or more triangles are congruent to each other, as well as just talking about congruent figures generally. Well, another way that we can relate objects and polygons to each other, both on and off a coordinate plane, is through something called a transformation. What this video is going to do is talk about three of the basic transformations specifically on a coordinate plane, being translation, reflection, and rotation. Now, transformations can happen on a coordinate plane, on a plane that doesn't have coordinates on it, or in three-dimensional space, but this video is going to focus on what it looks like on a coordinate plane. But first, what a transformation is. A transformation, by definition, is an operation that maps an original geometric figure, which we call a preimage, onto a new geometric figure, which we call an image. Go ahead, pause the video, write down this definition, come back when you're ready to hear a little bit more about what it means and said in slightly different words, as well as see examples and get some practice problems using each of the three basic transformations. Now, operation as a word mathematically is something that you've probably heard before as it relates to things like addition, subtraction, multiplication, division, etc., even exponentiation and taking roots. Those are all operations, meaning they are fixed ways that we allow numbers to interact, or we manipulate numbers to produce some other kind of result. We add two numbers together to get a different third number. And so, as far as a transformation being an operation, what that means is that a transformation is a fixed, systematic way of doing things that applies the same in every circumstance, depending on the transformation we're using. And that it's going to take an original geometric figure, called the preimage, do something to it, translate, reflect it, or rotate it, and it's going to produce a new figure that we call the image. Said differently, a transformation is a systematic method of changing the location of each point on an object in the exact same way. Go ahead, pause the video, copy down this description of a transformation, come back when you're ready to see the first type of transformation that we're going to see, namely a translation. So starting with a translation moves every point of the original figure of the preimage the same direction and for the same distance. So one way that we could talk about a translation is that we want to move this geometric figure up by 4 units, also called shifting it 4 units up. But what that means is that every point on this figure is going to move 4 units up. So if we take just this triangle's endpoints and move them up by 4 units, then we're going to see a new geometric object, preimage in black, image in red. We could also take this triangle and move it left by, let's say, 6 units. In which case, every point on that triangle is going to be moved left by 6 units, which means as long as we move the vertices of the triangle, we can just draw the sides between it. So, 2, 3, 4, 5, 6. And then follow with the same type of transformation for each of the units. So basically, a translation is just a slide up, down, left, right, diagonally, but moving the figure somewhere so that every point is moved the same distance in the same direction. Now, this isn't the only way that we can notate a translation. A translation we can describe using something called a transformation on x and y. And this is specifically on a coordinate plane, because on a coordinate plane, we assign x and y coordinates to every point. So in this case, we say that the transformation of xy is equal to some description of what we want. Well, if we want to move the figure left 3 and down 5, left 3 is negative 3 in the x direction, and down 5 is negative 5 in the y direction. So we say that is the transformation x minus 3, y minus 5, where the x and y of the original coordinates are plugged into the notation here, and then it describes how we move the figure. Down 3, or rather left 3 and down 5. So go ahead, pause the video, copy this definition of translation down, as well as any of the examples that we did here. Come back when you are ready to do a translation for yourself. So now that we know how to actually notate a translation and how to actually perform a translation, let's go ahead and give you a chance to do that for yourself. You're going to do two translations here. The first is going to be t of xy equals x y plus 5. And the second we will call t of xy equals x plus 1 y minus 1. So go ahead, pause the video, copy down the figure that you see on the left, go ahead and perform these two translations, come back when you are ready to see the answers and the images, and move on to the next type of transformation. So in the first type of translation, we can see that nothing actually happens with the x. Our original x coordinate is the same as the x coordinate we have in our image, so our x's stay the same. The x coordinate moves by 0. But the y coordinate is set to increase by 5, which means each of the vertices on this triangle are going to go up on the coordinate plane by 5 units. 4, 5, 5, 5, the other 5 there. And that is your new image. Now, how we mark an image on a coordinate plane is by using the same letters for each of the points, but by using a single apostrophe and calling it prime. So if the original triangle was ABC, the new triangle is A prime, B prime, C prime. Now for the blue translation, it asks us to move to the right one and down one, which is a relatively easy transformation to see. And then we can connect the vertices and get A double prime, B double prime, C double prime. So that's a translation. A reflection, which is the next type of transformation, flips an object over a line called the line of reflection. Each point of the pre-image and its image are the same distance from the line of reflection. And you may have noticed this when looking in the mirror, that objects in the mirror appear to be the same size and the same distance away from the mirror as the actual objects that are producing the image. Not to be confused with some mirrors on the right sides of cars that say objects in the mirror are closer than they appear to be. That's because of the particular curve of the mirror. But in a general flat mirror, like you might have in a house or an apartment, the image that appears to be in the mirror and the actual object that is projecting the image appear to be the same distance away, and that's the same thing for a reflection on a coordinate plane. Now we're going to talk only about horizontal and vertical reflections here, and so let's start by talking about it over the axes. So if we're looking at a reflection over the y-axis, we can take every point of this triangle and just move it, flipping it over the y-axis so it's the same distance away. Well, our upper right corner of the triangle is a distance of 5 away from the axis, so we just continue and move 5 again to get there. That is the image of, let's call it point A. The image of point B is 1 away from the y-axis, so its image is 1 away from the y-axis. Let's call that point B prime. And then C prime is also 5 away from the y-axis, or C is 5 away from the y-axis, so C prime is. What you'll notice is that the direction of the object is flipped horizontally, but that's what happens when we reflect an object over the y-axis. The same could also be true for the x-axis or for any horizontal or vertical line that we have. So go ahead, pause the video, copy down the definition of reflection as well as the diagram that you see here. Come back when you're ready to do a reflection for yourself. So this object, XYZ, I'm going to ask you to reflect in two different ways. The first is over the x-axis, and the second is, as we saw in the example, over the y-axis. So go ahead, pause the video, work on these reflections, find the coordinates for those points where x prime, y prime, z prime, x double prime, y double prime, and z double prime will be. Come back when you are ready to see the images, as well as move on to the final type of transformation. So as far as rotating this, or rather reflecting this, over the x-axis, two of the points are already on the x-axis. That's super easy. Their distance is 0, so their distance remains 0. The only thing that changes is that y is now 4 units away from the x-axis on the other side. So x and z are the same as x prime and z prime, and y prime is down here. For the reflection over the y-axis, again, we just count the distance to the y-axis and reflect over the same amount. So z double prime is there. X is a distance of 2, 4, 6, 8, 9 away. So 2, 4, 6, 8, 9 away for x prime. And then y is 5 away. So y is 5 away here, or y double prime. And then we have our new figure. And the final type of transformation that we have is something called a rotation. And a rotation turns an object around a center point that we call the center of rotation. Each point of the preimage and its image are the same distance from not the line of reflection, but rather the same distance from the center of rotation. So first, go ahead, pause the video, copy down this definition of rotation, and we're going to see an example of a rotation around the origin. Now, this is something you have probably almost certainly seen out in your life somewhere, which is that an object is rotating around a center point. So if our center point is the origin, for example, and we want to rotate 90 degrees counterclockwise, that means we want to rotate this object 90 degrees, circling towards the left when you're circling at the top of a circle. And we want each of our image points to be the same distance away from the center, which is the origin, as our pre-image points. So this is something that you can do visually. You can see that the right angle is made in the lower left-hand corner. So if we were to take the image and sort of rotate it over, that rather than the diagonal line being in the top right, you could see it flipping over and becoming in the top left. And so this is a very visual type of transformation. We can see that each of the points are the same distance away in the image and the pre-image, but the orientation changes slightly. In that, because it's a 90-degree rotation, lines that were horizontal become vertical, and lines that were vertical become horizontal, as well as the general orientation of the object on the plane is concerned. So there's not quite as nice a description as a translation, where we can say x plus 3, y minus 2, or a reflection where we can cleanly count distance away from a line of reflection. But in talking about a rotation, which is the third type of transformation that we're talking about in this video, and the third that belongs in this family of transformations with translations and reflections, if you can visualize an object rotating, or if you can draw an object on paper and actually rotate it clockwise or counterclockwise, then that will be really helpful. So what you're going to do is you're just going to do one rotation here. You're going to rotate this object, JKL. You're going to rotate it 90 degrees clockwise around the origin, where the origin is your center of rotation. So go ahead, pause the video, do that rotation, and you'll be ready to end the video. Okay, so in this particular rotation, we're going to rotate it clockwise, which means we are moving down to the fourth quadrant. So in this case, let's just actually unlock this object here so that we can create a copy of it, and then we can actually rotate it so we can see what this is meant to look like. So now we have JKL, and we want to rotate the object clockwise, which means we want to rotate the object that way. 90 degrees means horizontal becomes vertical and vertical becomes horizontal, and we can literally just turn the object. But we want all of the objects to be the same distance away. And so we can sort of think about this as L, the original point L, is a distance of 1 unit from the origin in the y direction and 5 units from the origin in the x direction. If we flipped that to be 5 units in the y direction and 1 in the x direction, we get point L prime. K has a distance from the origin of 1 in the x direction and 3 in the y. Move it or rotate it 90 degrees clockwise. That means a new distance of 3 in the y and 1 in the x, which makes that K prime. And then the same thing is true with j, just slightly differently, where we have a distance of 5 in the x direction and 4 in the y direction, which means 5 in the y direction, 4 in the x direction, and a new point j prime that completes the transformation. So 3 types of basic transformations: translations, rotations, and reflections, each with their own slightly different set of rules, but each that can be done on a coordinate plane.